Alright, so we are continuing chapter 3.1. We're still under computer networks. We're still looking at what is a network, what makes up that network, and so on. And we would have finished last week's class by looking at what are some needs to make a network. We need cables, we need a network card, we need a hub, a server, system software, and so on. So we're going to look at more what is a hub and the other requirements. So to get us started, let's have a reader for the paragraph on hubs. Let's see. Saskia, can you read for us?
Hubs. If you have a network in school, it is likely that the computers are connected by cable to a central device called a hub. One or more hubs, if there are a large number of computers on the network, are then connected to a file server. A file server is a high-performance computer containing large capacity hard disk drives that are available to all network users. It is where application programs and data can be shared to all users on the network. A file server is not used as a normal computer terminal, as its job is dedicated only to the task of managing shared files. Some networks also use a printer server that is dedicated to managing all printers on a network, where one powerful computer controls others. The network is called a what's this?
Hierarchical.
Hierarchical network.
Thank you for your efforts. So, quick question. Last week, I would have mentioned that today we do not use a hub. Does anybody remember the device I said that is replaced the hub? Letitia? Varshini? I see you were trying. What is the name of the device that is replacing the hub? Network switches. Very good, Gitanjali. So network switches, or a switch, is what is the device that is replacing the hub. So in the past, to create a network, persons would have used the hub, but today, because of the limitation of the hub, we make use of a newer device called a switch. The hub and the switch, if you were to look at it, they would look exactly the same. But just that the hub and the switch, they have the switch is more advanced in terms of building that network. It's there's some technical reasons behind as to why, so I don't want to go into detail unless maybe at the end of the chapter. If it doesn't, I will explain to whoever wants to understand as to why. So you have a network and you have cables, and those cables are plugged into this hub device. I think we should have a diagram somewhere. Yeah, like this diagram here. So the hub is like a central device, and the cables are all connected to this hub, and all the devices are connected to the hub, and that hub now is connected to either your modem or your router, so that they can have maybe internet connection or so on. But not being connected to a router or a modem does not mean they're not a part of a network. Just being connected by themselves, they are a network. Just that they are not connected to that larger network of the internet. So one or more hubs would be needed. Now, depending on the size of that network, how many devices need to be connected to that network. The next device that we need is a file server. Now, can anyone remember why we create a network? What was the main reason we create a network? For what purpose?
To share and transmit data.
Very good. To share and transmit data. So, because we can share and transmit data, we can communicate, we can send email, we can send videos, we can send audios, and so on. Now, say for example, you have the school network. And say for example, this is a school network in this diagram that you're seeing here. The school might set up this network to share school information. So teachers might share homework, they might share assignment, they might share notes, and so on. So how are they sharing these notes? Where are the notes located? Where are the assignments located? They will be located on a computer called a file server. Anybody else having a problem hearing me? Seems Ryan has a problem. Is everyone
No,
is everyone hearing me?
no, sir. Yes, sir. Yes, sir.
Okay, so someone indicate to Ryan it's his issue. Yes, that file server is what will contain all of the files for the network. It's as the name indicate. The computer, the file server is a high capacity computer. It has large storage, and the other parts are designed so that they have high performance. So the word server means that it is serving. It will be serving whatever the word is in front of it. So it will be serving files. We also have another server at the bottom here called a printer server. And that printer server will be serving printers. So you can have a printer connected to the computer, to the network, sorry, and you can share those printers on the network. So then that server now becomes a printer server. So depending on what is being shared, that would be the name of the server. If it's a file server, printer server, and so on. But the main idea is that there is a central computer on the network called a server, and that server is what will host all of the data that is going to be shared. Now, it doesn't mean that you need to have a high capacity computer in order to share, but just that in large networks, it would make more sense to have a dedicated computer in order to share those data and resources. Alright, so looking at the diagram once again, this is the layout of a network. Almost anywhere you go, you will find this layout. The network layout will always be similar to this. You have a central device, say for example a hub or a switch, and the other devices that want to be connected to that network will connect to that hub or that switch. What you have at home, you have a router. Yes, a router. And as I would have explained last week, the router that you have at home is made up of the device called a switch. So the switch and the router is built into one. Now, so that is why you can connect wirelessly for devices like your phone, tablet, and your laptop, and you can also connect devices with the wired connection, such as your desktop, your laptop, your printer, and so on. So it has both devices into one, and if you can imagine it, it actually looks like this diagram. It's a central device, the router, and all of the device in your home is connecting to this central device to form that network. Alright, let's go on to the next one, peer-to-peer network. We look at what is a peer-to-peer network. Amelie, can you read for us?
Yes, sir. When a network does not have a file server, it is called a peer-to-peer network. In a peer-to-peer network, each computer acts as a server to the other computers, its peers, on the network. The peer-to-peer network also allows users to access each other's hard disks and peripherals.
Good. So, as I mentioned before, the file server is used on a large network because it doesn't make sense that everyone has the data scattered. Say, for example, the school, the lab. It doesn't make sense that the data that you want to share is scattered on all the computers in the lab. So you have to go and search each computer to find the data that you're looking for. So when you have a large network, it makes more sense to have all of the data, all of the resources on a central computer. That is why you would have a server. But when you have a small network, it doesn't really make much sense for you to have a server because then you will have more cost and expenses and so on. So in those cases where you do not have a server, it is called a peer-to-peer network. So all the persons that are on the network, say for example, what you have at home can also be considered a peer-to-peer network because there is no file server, there is no server at your home. So in order for you to communicate with the devices or share resources with the devices that you have at home, that will be considered a peer-to-peer network. So you have, say for example, two laptops connected to your network at home. You can send music from one laptop to the next or send a video from one laptop to the next. That is considered a peer-to-peer network. Each peer on that network or each computer on that network will act as the server. So if at any time your computer is sending a file, your computer is acting as a server. So the word server is not only for high capacity computers, it's any device once it is serving data or resources or so on. You guys following so far?
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
So what we'll be going into next is the layout. Now, throughout the years, there's been different revision to how we set up the network, the different layout and so on, because obviously we want better performance, more speed, more data to be transferred and so on. So there's a few layouts and some can still be used today, but we'll be looking at the different layouts, why they are used, what are the advantages, what are the disadvantages, and so on. So let's see. Okay, so bus bottom there. So let's have someone read the next two paragraphs: network layout and star layout. Let's see. Ryan. Oh yes, Ryan wasn't hearing us. Robert?
Network layout. If a file of a computer network is functional, there are three main types of layouts.
Topology.
Topology of computer network. Star, bus, and ring. In a star network, all the nodes are connected to a central hub. This means that each computer has its own connection to the network and that a break in the cable will not affect the working of other computers. If the hub breaks down, then all computers in the hub will not work. However, star network sites are a little more expensive to install than other types of equipment.
Good. So, when it comes to computer networks, there are three main layouts that you will have, or three network topologies, you can say also. There is the star, there is the bus, and there is the ring. Now, those words, star, bus, and ring, you can imagine the network exactly as the word exactly as the word indicates of the shape. So a star would have many points. So if you look at the diagram here for a star network, you can see it has a central device and it has many points. It has 5 points here. Now it can have more than 5. So that would be considered a star. Now a bus goes in a straight path, in a line. So if you look at the diagram here, figure 3.3, you will see all the devices are connected to the one after each other. So this desktop is connected to this desktop, then this desktop is connected to this laptop here. They're connected in a straight line, like how a bus would go across a path. And then we have the ring, which is a circle. So all the devices are connected in that ring. So when you're thinking of the network layout and you remember star, bus, and ring, imagine the shape that they have, and that will give you an idea as to the network, how they're configured. So in a star network, all the nodes, so a node is another word for device. So a node is another word for a computer that is connected to the network. So all the nodes are connected to a central hub or a central device. It could be a switch, could be a router. Once there is a central device and they're all connected to that central device, it is considered a ring network. Now this means that each computer has its own connection to the network. So each computer has its own wired connection. Now it could also be wireless. So say for example, these two laptops at the bottom here, they could be connecting via Wi-Fi. So it doesn't mean that they have to be connected by a cable. They can be also connected via Wi-Fi. Once they have their own connection to that central device, it is a star network. Now the advantage of this is that a break in a cable will not affect the working of other computers. So if this cable over here was to break at the top computer, it will not affect the other 4 computers. If the Wi-Fi went down for these 2 laptops, it will not affect the cabling for these 3 computers at the top. So that's the benefit of a star network. If one computer is down, or if the network cable for that computer is down, it does not affect the entire network. It does not affect the rest of computers and cables on the network. They will continue to run. Now, if the hub breaks down, then all computers connected will fail. So obviously if this central device goes down, the entire network will go down also. So that you can say that device is called a central point of failure. Once this device is down, the entire network is down. So that's the disadvantage there. But however, star networks, although more expensive to install than others, are the quickest. So quickest in terms of what? Quickest in terms of data transfer. So compared to all the other networks, the star network has the fastest data transfer, and that is why almost anywhere you go, you will see a star network. What you have at home is also a star network. All of your devices are connected to that central router that you have at home. So that is a star network. It has more speed, but the disadvantage is that it is more expensive, because if you have multiple desktop in your home, you have to buy more cable to run to each desktop, and that will cost you more there. So it only costs you more in terms of the cabling, because you have to run a cable to each device now. So that's the advantage and disadvantage of a star. Let's look at the bus now, the bus network. Gitanjali, can you read for us?
A bus network is the simplest type of topology where the network nodes, computers, are aligned as shown in Figure 2.2. Bus networks are cheap and reliable, but if the cable breaks, the network is fully. Unconnected parts. Bus networks are slower than star networks. The speed of network traffic is limited to 10 megabytes per second.
Good. So the bus network is the simplest to set up, and all the nodes or the computers are connected in the same line. So as it is in this diagram here, they're all connected. You can see it's like a central cable. So it's something like your backbone. Your backbone runs up your spine runs up your entire back, and all the other parts are connected. So all the computers are connected to that central cable. Now the bus network is cheap, it is reliable, so that's an advantage there. So it's cheaper to set up than the star network because it's one cable. You don't have to buy a cable for each device on the network. But the disadvantage is that if that cable breaks, you will split the network. So if the cable was to break right here, then this computer will be by itself, and this computer and this laptop over here will be by itself. These two devices will still get to communicate because the cable is still connected to the two of them. So if the cable was to break in three places now, between these two desktop and between the desktop and the laptop, then that means you don't have any more connection in terms of this network here. So wherever the cable would break, it would end up creating more network, and those devices would not be able to communicate with each other. Now a bus network is slower than a star. It would have a speed limited of 10 megabits per second. Remember, we learned this last term. A lower b refers to a bit. A capital B refers to a byte. So there's a difference between a bit and a byte. And one thing that you guys should take note of, when we are talking about network speed, anytime we are talking about network speed, we never say bytes per second. We always say bits per second. I don't know if you guys ever noticed, but when GT&T is advertising, they do not advertise megabytes per second. Any of you ever noticed that? Let me see. Where are the plans? One more. Right. Can you allow me to scroll to the right? Okay. Oh, I have to go down. Yes, if you notice in the image here, they have a common B. For all the B's, they have common B's because network speed is measured in bits, not in bytes. So that's why you will always see bits per second, and that is what may confuse a lot of persons, because they might be saying, "Oh, I'm supposed to be getting 5 megabytes per second," but in actuality, you are getting 5 megabits per second. So when you do the conversion now, you would see that your download speed is correct, because I think 5 megabits is supposed to be about. Alright, let me not hurt myself. Anyway, you guys get the idea. So network speed is measured in bits per second, not bytes. So always take note of that. If you want it in bytes, you would have to do that 8-bit conversion. Alright, the next paragraph, we're going to be looking at what is the ring network. Let's see, Murano.
Okay. So I'm just going to read that. Okay. 720%.
What did you say?
I'll read from my book.
Okay.
Can you please get that from? Because I'm seeing it blurry and so is it from like the bus?
Yeah.
Network?
Yes.
Okay. Alright. Unlike the bus network, a ring network has no end to the line. The last node computer is connected to the first node, forming a ring or loop. As with the bus network, if the cable breaks, will affect all the computers on the network. Ring networks are also slower than star networks, with the speed of network traffic limited to 10 Mbps per second.
Good. So the ring, you can say it's almost similar to a bus, because if you think about it, if you loop back these two ends to each other in the bus network, it basically will become a ring. So the ring has similar disadvantage and advantage like the bus. If a cable was to break at any point, you are going to lose the connection to that part of the network. Now, if I think how the ring operates is that it goes in one direction. If I remember correctly, I think the ring only goes in one direction. And so if a part was to break, then that means the network would not be able to communicate with each other, because I don't think it goes in the other direction. I might be wrong about that, but I think that's what I remember learning. But just note that if the network cable was to break, then it will affect the network. Now, once again, the limit disadvantage is that of the speed of the network. So the network is once again limited to 10 megabits per second, just like the bus network. So even though the ring network, the bus network, they're the cheapest to set up, they are the easiest to set up, we mostly want our network for speed, for the transmitting of data. So that is why, even though the star is the most expensive, you would see every person creating a star network. Why? Because we want speed when it comes to transmitting our data. All of you want speed when it comes to transmitting your data. When you're sending a picture, when you're sending a video, you want it to reach right away. So that is why most persons would make use of the star network. Even though it's more expensive, it is more reliable and it has more speed than the ring and the bus network. Alright, the next paragraph, let's have Suraj. Suraj.
The Internet is a vast collection of computer networks spread throughout the world, which involves all these different ways of linking computers. The most common way to link computers on a network is by cables such as fiber optic or telephone lines. Wireless networks, however, are linked by infrared wave or microwave or radio wave.
Good, read the next paragraph for me. Let me see how far that goes. I think it goes across, hopefully. Let me see that's yeah. Read the next paragraph.
WLANs use high-frequency radio signals, infrared light beams, or laser to communicate between the workstations and file servers or hubs. Each workstation and file server on wireless networks has some sort of transceiver or antenna to send and receive the data. Data is relayed between transceivers as if they were physically connected. For longer distances, wireless communication can also take place through mobile telephone technology, microwave transmission, or by satellite.
Very good. So, as I would have mentioned last week, it does not matter how you are connected to the network. You can be connected via a cable, you can be connected via some sort of wireless technology such as infrared, microwave, radio wave, you can be connected via string and all. Once you are connected to that network and you are part of that network, you can share resources and data. You are part of that network once you are connected. So these networks that we looked at the top here, the ring, the star, the bus, well, the ring and the bus, obviously they will be using a cable. So those will be making use of a cable because you can't make a wireless signal into a ring. You can't make a wireless signal into a bus, into a straight line. So in those cases, you won't have any wireless connection. But for the star network, you can have a wireless connection because then each device will be connected to that central device. So when it comes to the wireless connection now, so WLAN or wireless LAN, they use high frequency radio signals. Some can make use of excuse me. Some can make use of infrared light beams, lasers, and so on. So it does still it does not matter what technology they use to connect to the network. Once they are connected, they are a part of that network. Now, for these wireless devices, they would have two features. They would have an antenna, and that antenna would be called a transceiver. So that means that this transceiver, this antenna, can send and receive data. So a receiver is a device that could only receive, and a transmitter is a device that could only transmit. So a transceiver is a combination of those two features. It can transmit and it can receive, so it can send and receive data. And as I would have mentioned, a very popular example of this is your network connection to your cellular network connection. So all of you have a phone, all of you have a SIM inside of that phone, you have a phone number. That is a wireless connection. You are connecting to some sort of antenna, either digital or GT&T, and you are transmitting and receiving data all of the time. So this here is a diagram of, let's see, remote computers can connect to the LAN through transceivers as if they are physically connected. Transceivers are often built into hubs, laptops, portable devices. So your phone has a transceiver, your laptop, your router, all of those devices have a transceiver because they need to be able to transmit and receive. And the transceiver would make that wireless part of the network seem as though it is the same as the wired part of the network, so that they can all communicate with each other. Alright, let's look at some other examples of wireless connection. Let's see. Crystal. Don't we have two crystals in this class? We only have one currently. Crystal Simon. Simon, are you there? So you joined late and you're still not there. Alright, let's have Saeed. Saeed?
Yes, sir.
Can
So
you,
where are we?
Bluetooth?
Bluetooth and Wi-Fi. Short for wireless
Fidelity.
fidelity. Both provide wireless connectivity using radio waves. The main purpose of Bluetooth is to replace cables, while Wi-Fi provides high-speed wireless access to a network or the internet. Bluetooth allows for the exchange of data over short distances among wired and wireless devices. WLANs provide easy access to information between wireless devices from different manufacturers. Devices with Wi-Fi, such as computers, mobile phones, game consoles, or MP3 players, can connect to the internet if a wireless network is with a certain range.
Continue.
A hotspot is a public area as small as a room or as large as many square miles that offers internet access over WLAN. Wi-Fi hotspots can be in cafes, airports, and hotels. Wi-Fi connections can be made up to about 300 feet away from a hotspot. To keep users connected wirelessly while commuting, customers may have to pay for the service.
Very good. So we have um, three options when it comes to wireless connection. The first, we have Bluetooth. Most of you should be familiar with Bluetooth. You have it on your phone. Now, the purpose of Bluetooth is to replace cables. So, if you want to quickly transfer a file and both device has Bluetooth connection, you don't need a cable anymore. You don't need to be a part of a network, a larger network. Once you form that Bluetooth connection, you make that network connection between the two devices, and you are able to share your data. You can share your pictures, your videos, and so on. Now, the Wi-Fi now, but the limitation of the Bluetooth is speed. All of you who would have used Bluetooth, you should know that our Bluetooth it's relatively slow. You have to wait a long time for a music to send over, a video to send, and so on. But we can say the advantage of Wi-Fi is that we have high speed connection, so that we can transfer data much faster. You would know how fast it is to download an MP3 file from the internet or a video or so on, as compared to a Bluetooth connection. Now, a Bluetooth connection, it's used for exchange of data over short distances. So, a few feet away from a person, you would use a Bluetooth connection so that you can share that data. You can exchange that data. Today we have many devices with Wi-Fi connections. We have computers, phones, even your game console, your MP3 player, almost any device today would have a Wi-Fi connection. Even some smartwatch, they have Wi-Fi connection, because many persons know we want to share data, so they make that connection available. Now, the third kind of wireless connection that we have is a hotspot. Um, Most of you should be familiar with this also, because when you went to school and you connected to the school Wi-Fi, whichever one of you was fortunate to connect to the school Wi-Fi, or one of you get data, you would turn on your hotspot and share that internet connection with all of your friends. So most smartphone devices would have this hotspot feature built into them, whereby they can share a network connection with other devices within a certain area. But a hotspot connection doesn't only mean it is being transmitted from a phone or some sort of laptop or so on. It could also be a dedicated device, like for example your router. Your router could be considered a hotspot also. If you set up like different routers all over a building, for example an airport or a hotel, when they set up those different routers to cover different parts of that large building, those are hotspot areas where you can get a Wi-Fi connection. Alright, you guys following so far? Any questions? Alright, let's just look at the advantage and disadvantage, and we're gonna stop at that part for today. So, advantages and disadvantages, we're looking at the standalone computers versus network computers. What is the advantage and disadvantage of both of them? So, let's see. Emily, you can read the advantages of standalone computers.
Advantages. Standalone computers. Ideal for most home users. No network card needed. Can be dedicated to a specific task, example composing music. No need for network software license. Only single user license required. Security from users on other sites.
Good. Before we get into it, does anyone remember what a standalone computer is? Kezia?
Source Keziah, a device that only is portrayed or used for one thing.
Let's try someone
Or
else.
specific
You want to try again, or we can go for somebody else? Looking for something specific. Pamela? Varshini? It is used on
Network connection.
What was that, Pamela?
Sir, it can work without LAN connection.
Okay, good. Basically, yeah, it works without, it can work without a LAN connection. It is used on its own without requiring connection to a LAN or WAN. Yes. So, basically, any device that is not a part of a network, any device not a part of a network, that is a standalone computer. So, standalone in terms of the network, it is by itself, not connected to a network. So, what's the advantage of a computer not connected to a network, a standalone computer? Well, it is ideal for most home users. There are some persons who don't need a network connection. They just want to be able to go on the computer, play music, watch videos, edit a few documents, and so on. They don't need any connection, so they don't need any network card. It's because they're not connecting to any network. You can dedicate the computer to a specific task. For example, composing music, editing videos, and so on. And fourth one, you don't need a network license, so less cost on you. And security from other users and other sites. So a standalone computer is secure because it's not connected to any network. It can't be infected by anyone sending any virus to the computer and so on over the network. But what are the disadvantages? Darrell, can you read the disadvantages?
So can you hear me?
Yes.
Disadvantages. Cannot easily share data, particularly large amounts of data with others. Data can be transferred only by disk or by modem. Will need to use an external hard drive or online storage, which can be time-consuming and unreliable.
Good.
Network cards.
That's the other one. So
Network cards, cabling, hubs,
don't need
and
to read out
servers
that.
can.
So those two disadvantages at the top are for standalone computers. The first one, well, obviously, if you're not a part of a network, then you can't easily share data. You can't easily share resources. And that's the biggest disadvantage. You're not able to share anything. So, yes, you're dedicating your computer for a specific task, such as composing music. But when you finish composing music, when you finish editing the photo, how are you sharing that photo? You're not a part of any network. So it's much more difficult for you to share anything that you are making. So if you have large amounts of data, or if you have any data, in order for you to share that resource, you're going to need some sort of network connection. You will need a network connection in order for you to share that data. Or if you don't get one, you would need some sort of secondary storage device to transfer the data to that and then share it with whoever you want to share it with, which is going to be more time consuming. So let's look at the advantages now of a network computer. Let's have Anthony.
Yes, sir. Access to network computers from any workstation. Share files with and send messages to other computers. Share resources such as disks, drives, CD-ROM drives, modems, or printers. Share programs such as word processing, spreadsheets, or database software, which are stored centrally. Possible for network users to work on the same file rather than each user having their own file. These programs are cheaper per user than one-off software for standing-alone computers. Activities of network users and such things as amount of storage space available to users can be controlled by a network manager.
Good. So, first advantage, access to network from any workstation. So, if you're a part of an organization, all of those computers, the devices will be a part of the network. So it doesn't matter what computer you go to, it will be a part of the network and you will be able to access the network. So you will be able to access any resource that is on the network. So that's the first advantage. The second one is basically you are able to share any file, data, resource, anything that you have. So the second, third, and fourth is basically that. Any file, resource, program, anything that you have, any data, once you're part of that network, you are capable of sharing. You can share your hard drive, your printers, you can even share programs. So that's the other advantage that we have. We can share programs. And because we can share programs, it means that we have a lower cost. Because we don't have to buy a program for each computer now. We can buy maybe one program and then we can share that program over the network. So we're only buying license for one program and all the other computers on the network will be able to make use of that one license program, thus cutting down costs. Now the last advantage is activities that users will be carrying out and how they are using the computer can be controlled by a network manager or a network administrator. So what you do on the computer, what you store on the computer, it can all be controlled by a central person. They can say, look, you can't play music, you can't play videos, you can't browse the internet, you can't do those things. That's the advantage of a network computer. They can control what you are doing. So you don't use the people computer to watch anime whenever you feel like. Now, but what are the disadvantages of a networked computer? What's the disadvantage? Let's have Jonathan.
Yes, sir.
You're reading the disadvantages.
I'm reading from network cards.
Yes.
Network cards, cabling, hubs, and servers can be costly. Wireless connection to the network may result in reduced data transfer rates and unreliable connectivity. If the file server stops working, known as a crash, it can stop everybody on the computer on the network from using a computer. Poor security. With more users, there is a greater risk of computer viruses and of unauthorized users, hackers, gaining access to network data. Need for a network manager to manage the system. This can be costly.
Good. So the first disadvantage, the cost. You need to pay for network cards, you need to pay for cables, switch, routers, server, all of those things. And it will add up. It will cost you a lot. Even when you're setting up wireless connections, there's a disadvantage with that is that you will have slower transfer speed or slower transfer rates. Always remember that a wireless connection is going to be usually slower than a wired connection. So you're going to get slower speeds, and it can also be unreliable because if you go outside of the wireless range, then obviously you won't get a connection. Or if something is blocking the signal, you won't be able to get a connection either. So that's one disadvantage of the network computers. The second one is that central point of failure. All of the computers on the network is relying on that file server to be able to work. All of the resources, all the data, all the files are stored on this server. That's how persons do their work. So if the file server is to crash now or it stopped working, then no one in the organization will be able to do their work. So that's one disadvantage there, another disadvantage. The third disadvantage is poor security. As more persons are connected to the network, as we have more computers on the network, it means that we have more points, you can say, that a person can use to access the network and basically hack the network. So, say for example, you have a large building, it's an organization, and almost every computer in that building, a 4-story building, each floor has computers. All of those computers are connected to the network. So now, a person can be any part of the building, any one of the floor. Once they find a computer, they can be able to hack into your network. So poor security comes about because of this network configuration. And that is why we have the fourth point now, because you're going to hire a network administrator or network manager to look after the network, because you don't want those hackers to get into your network. But now when you hire that person, it's gonna add more costs to your organization because you're paying for an additional employee, sometimes even multiple persons, to manage that network and the configuration and so on. Alright, we're gonna stop here for today. So, in review, today we looked at a lot today. We looked at some devices that we need. The hub, it was replaced by the switch. It is the central device. We looked at the network layouts that we have. We have the star, bus, and ring. Remember, when you think of the name, think of the shape. The star looks like a star, the ring looks like a ring, the bus looks like a straight line, a straight path. The disadvantage of the bus and the ring is their speed, but the advantage is that they're cheaper. The star, you will get more speed, so that's the advantage, but the disadvantage is the cost, because you have to pay for all of the equipment. And it does not matter how you're connected to the network, whether it's cables, whether it's Wi-Fi, whether it's Bluetooth. Once you're connected to that network, you are a part of that network. Alright, so we can end here for today. If you guys don't have any questions, enjoy the rest of the video.